All right, that was multiplying radicals. And I'm just going to revisit that up here. We're not quite done, but if you notice, all of the radicals in A through F were monomials. So let's up the degree of difficulty a bit. And I'm going to underline each term of a polynomial just to make sure that we're understanding. So this is one factor, 3 root 7 is one factor. That's a monomial. And we're going to be multiplying it by 5 root 5 plus 3 root 2. So this second factor here is a binomial. So just like polynomials, a monomial times a binomial, you'll have to make two different multiplications. So I'm going to show perhaps my work and try to get away from it and maybe do a little bit more mental math so it's less hard lifting. So I'm going to do this first multiplication first. 3 root 7 times 5 root 5. So that's going to be 15 root 7 times 5. In other words, I multiplied the coefficients 3 and 5 and the radicand 7 and 5. I'm going to go on to the second multiplication now. 3 root 7 times 3 root 2. And what we'll end up with is 3 times 3 is 9. 7 times 2 is 14. So I'm just going to maybe clean this up a bit. So I would write this as 15 root 35 plus 9. Pardon me, that's 35 plus 9 root 14. This example just really showed us the pattern in multiplying. Really nothing in simplifying. Perhaps we'll get something a little bit more interesting in the next example. H, what we're going to do is there's a monomial, and I'm going to be multiplying that into the binomial. So 1, multiplication, and after I'm done with that, I need to do that second multiplication. So I'm just going to take a look at my radicands here. 3 and 7. Well, those don't share a common factor, do they? So that's going to be kind of an important fact. So I'm going to multiply the coefficients just to be sure, because there's a lot of 3 and 7s going around. So 7 times 3 in the coefficients creates a coefficient of 21. And then I'm going to multiply my radicands. 3 times 7 is 3 times 7. Now I'm going to do the second addition or multiplication here. 7 times negative 4 root 3. So I'm just going to multiply my coefficients. So 7 times negative 4. And that creates negative 28. So 7 times 4 is negative, or 7 times negative 4 is negative 28. Now I'm going to multiply my radicands, which is 3 times 3. And 3 times 3, so that's going to be the square root of 3 times 3. Okay, there's something a little bit different about this one. So this, I'm just going to simplify 21 root 21. Okay, that's interesting, but not where we're going here. But the root of 3 times 3. Now, 3 times 3 really means 3 squared. So the root of 3 times 3 is going to be 3. So this number right here is going to be an integer. I just don't know what it is yet. So 28 times 3. So that's 4. Give it the 2, 84. There it is. So this is 21 root 21 minus 84. Generally speaking, we write the constant term first because its degree is 1. And then we write the radical next. Wow. Things kind of got crazy there. Anyways. All right. I think maybe I'm just going to go to K and L. Now, if you recall, while we're taking factoring binomials, a perfect square factors into the conjugate. I don't know if you can see this, but once you see a conjugate, once you train your eye, it's pretty hard not to see them. So those first terms are the same. Those second terms are the same. However, the operation within each binomial, one's a plus and the other one is a minus. So this is a definition of a conjugate. What we're going to see is when we multiply conjugates, we're going to expect to see a difference of squares. Let's just stop talking and let's get down to it and just do it. So it's a binomial 1, 2, 3, 4, right? So I have each binomial has two terms, so I'm going to have to do one multiplication and two multiplications. I'm going to call those the red multiplications, and then I'm going to say, then I'm going to go on to the gold, and there's two there. So in my first red multiplication, I'm going to say 2 times root 3 is going to be 4 times the root of 3 squared. Or, keeping it consistent with how we've been doing things, I could write it as the 4 times the root of 3 times 3. Now I'm going to go on to this next multiplication. 2 root 3 times negative 3 root 3. So I'm going to multiply the coefficients. So my coefficients here are 2 and negative 3. I'm going to multiply that. So that creates a coefficient of negative 6. I'm going to multiply my radicands, 3 and 2. And that creates a radicand of 6. So that's it for my red multiplications. Now I'm just going to go on to my gold multiplications. This term times this term. So I'm going to multiply my coefficients. So positive 3 times 2. So I'm going to be adding 6. And my radicands is 2 and 3. And that creates a radicand of 6. Now I'm not done my multiplications because I have to carry out the second multiplication. So I'm going to multiply in this 3 times negative 3, and that creates a term or a coefficient of negative 9. And when I multiply my radicals, root 2 times root 2 creates the square root of 2 squared. And what is really interesting is when we multiply conjugates, and we'll see a lot of this later, is that this middle term actually cancels out. But let's get on to this first term. So this is 4. Root of 3 times 3 is just 3. Now this blue, what I've highlighted in blue, negative root or negative 6 root 6 plus 6 root 6, well, this is just really adds to 0. And minus 9, the square root of 2 squared is just simply 2. So, pardon me, I included one too many negative signs there. So really, this ends up being 12 minus 18, and the answer is negative 6. So notice how we started off this crazy expression with 4 different radicals, but when we multiplied through, we came to an integer number. And that is the magic of multiplying conjugates. Okay, I would encourage you to press pause on the video, try this next example, and I'm going to proceed. So whenever you're ready, unpause and see where you get. All right, so I'm going to have to do 2 multiplications. 2 root 3 times 2 root 3, that's going to be 2, the square root of 3 times 3. And the second multiplication in red, 2 root 3 times positive 4. Now 4 can be thought of as a coefficient, so that would be 8 root 3. I'm going to move on to the gold multiplications. Negative 5 times root of 3 is negative 5, pardon me. Negative 5, pardon me, negative 5 root 3. And negative 5 times positive 4 is negative 20. So I'm going to simplify this up. So this is 2 times 3. So, and what I recognize is that we have like terms right in the middle. So 8 root 3 minus 5 root 3, well, that's just going to be positive 3 root 3 minus 20. And my last term is minus 20. So I'm going to take one more line, maybe 2. So 2 times 3 is 6, plus 3 root 3 minus 20. I'm going to combine 6 and negative 20, which creates a term of negative 14. My radical is 3 root 3.